Hi, grade 5 teachers. We are going to take a look at our next topic in theme 3. We're going to be looking at operations with decimals. You'll notice has 4 different chunks because all 4 operations are within the same standard. So we're going to be looking at addition with decimals for the first 2 essential tasks, 52 and 53. We're going to be looking at subtraction on essential tasks 54 and 55. And then you'll notice there's going to be 4 tasks for multiplication, so 56 through 59, and 4 tasks for division, 60 through 63, excuse me. You'll also notice that we have these resources in the middle, just like as before, some videos that you can use, parent newsletters, discourse card questions, 3-act tasks, blank strategy slides. Definitely utilize this when you are creating extra practice or assessment options or opportunities. You'll also notice we have those CRA mats. Again, in those instructional notes, just a reminder, we are using the same exact strategies that we would use in brick and mortar or inside the school building if we're working in a virtual world. So this video really is just focusing on addition and subtraction. So we're going to be looking at essential tasks 52 through 53 and kind of thinking about how students are expected to be able to use the standard algorithm when adding and subtracting with decimals. However, not all of our students are going to be there yet, and that's okay. They should be able to demonstrate their understanding in other ways. So if they're not ready for that standard algorithm yet, don't worry about it. It's just probably going to take them a little bit longer when they're multiplying and dividing, and that's okay. So really making sure that we are not focusing on rules for any of our decimal computation. We're not lining up decimals, right? We're really talking about place value, and we're really talking about that conceptual understanding of what we're doing. And we're really going to be focusing on reasonableness, right? So thinking about what would a reasonable answer be? Why do we think that? How do we know? And then double checking our answer when we get it. Was our answer reasonable? Do we need to go back and relook? So let's dive into our first 4 essential tasks. Essential task 52 is going to start us with addition. You'll notice here in the notes, excuse me, in addition to it being laid out here in the scope and sequence which operation, you'll also notice I highlighted the part of the standard that these tasks will be addressing. So let's look at some of our addition strategies. So we have multiple options here. This one option is with place value discs. So think about how students are going to share their thinking. They could either use the discs in this slide. They could use the Didax app, which is linked here, that will take them to place value discs and they can copy and paste, or they could take a screenshot of their work. The other option is they could tilt their camera down and use their place value discs and insert a picture. You'll notice these little equations on the side. Students can just go ahead and type in. So double click and type in this case, the addends and the sum. They could drag an addition sign over to notate that it is addition. So that's one option. Our next option is using place value blocks. They could use these blocks here on the slide, drag and drop, or they could use this number pieces math app. Every time this number pieces math app is there, you'll notice that the problem is also put in the slide. Sorry, I don't know why my computer's going so slowly all of a sudden. Okay, here we go. So the problem is here, and I've also notated what one whole is. When we're using place value blocks, we need to constantly be referring to what our whole is, because as we know from our other decimal units, the value of these can change. Then you'll notice our place value grid, our grids of 100. In this case, these are grids of 10. So we can, if one large square is one whole, each column would be 1/10. So they could shade, right? They could drag, drop, resize. So I could show you my 7/10. Oops, sorry. And then I could show 5/10 added onto that. And what's cool about doing it this way is I could decompose my 5/10 and I can really show you how I could make one whole. Kicking it back to strategies, some primary strategies for addition, right? So I have 7/10. I'm going to take 3/10 from my 5/10, and I know that I have 2/10 left. So this is an option to kind of help show really right now that's really eliminating that need to regroup, right? Because in my other strategies, I'm really going to have to show that regrouping. While here, I'm working on making that 10 as my strategy. So once again, we are talking about estimating, we're talking about reasonableness. So if I was, before even solving this problem, I would look at it and say, do I think my sum's going to be greater than or less than one whole? Why? Right? So I would hope that some of our students would be able to say, 5/10 is half, right? That's halfway between 0 and one whole. 7/10 is greater than that. And I know that 1/2 plus 1/2 is a whole. So I know that my answer is going to be greater than one whole. Not much greater, but definitely greater. And we can see that here with our models as well. The other thing, I'm sorry, that I forgot to mention when we're talking about our grids is in your packet, the printable packet, students received these grids that they can use. So I could also demonstrate my thinking. I just slid it right into my communicator or my clear plastic sleeve. I can tilt my camera down and I can show my thinking here as well. So that's another option, just kind of thinking about a non-computerized idea here. We definitely want, you'll notice we're really making sure that we're connecting those strategies, because as we continue to get greater numbers, some of our strategies are going to be less and less efficient, right? When we start larger or greater numbers and we're building with more place values, and we need bigger place values, blocks, right? Those place value blocks are going to kind of expire for us. That's not going to be our best go-to strategy. So thinking about how we can kind of push our students thinking what's efficient, what's effective. We have one more try it out slide here. This one has 1 and 2/10 plus 9/10. So once again, we're thinking reasonableness. What it would be a reasonable answer? Is it going to be greater than 1? Is it going to be less than 1? How do we know it will be greater than 2? So just kind of thinking about what would be reasonable, and once we get that answer, we're going to go back and discuss, well, was I correct? Well, you'll notice here, and consider using some more examples from students instead of these, but just those different strategies being represented and how we can show 2 and 1/10. There is a video here for students to try. Just kind of noting that this video, this interactive video from Ready Common Core, is going to have students use the standard algorithm. It builds up to the standard algorithm, but they definitely are going to be using that. If that's not appropriate for your students at this time, you might want to consider having them practice with whole numbers first. There is an interactive video with whole numbers instead of using the one for decimals. That's up to you. You can find that in the teacher toolbox. Our next essential task 53, we're going to stay in that world of addition. Same strategies, except we're really going to start to see here and think about efficiency. So I kind of touched on this on the last video, thinking that we're going to start to reach a point where building some of these numbers is not going to be as effective or as efficient as it once was. So we're really going to need to make connections for students and kind of help them see what other strategies they could possibly use. Once again, make sure that you discuss reasonableness. What would make sense here? Do we think it's going to be greater than 4, less than 4? Will it be greater than 5, less than 5? Before we even dive in and get started. Like I said, same strategies that you saw before. You'll notice here we're getting into that. We're going to see more place value blocks, especially with our next try it out problem. We're also, when we're looking at our grids, it's going to be a little more challenging on our grids as our numbers get greater. But that's okay because it's still going to work. They're still going to be able to show it. And here we're going to also have the option for the standard algorithm. It is totally up to you if you want to share this option with your students before making connections to it. I would definitely think that it would depend on how your students did with, or showing how they did with the standard algorithm of whole numbers, which you probably saw when we were multiplying whole numbers. Anyways, you'll notice the purpose of this top row, you might see that there are more rows than needed, is to really show that regrouping. And this will be in a different color. That top row is going to be in blue, whereas these other rows are going to be in black. So you'll definitely be able to see that regrouping stands out. It looks a little different. So here, though, our purpose really is to connect other strategies to the standard algorithm. So even if a student did not show the standard algorithm, you will notice here is a picture of the standard algorithm. You can use a student work sample instead of this one. If you want to delete this, you totally can. That is an option. Just click it, delete it, it'll go away. So feel free to do that if you would like to. But remember, we're really making that connection. We're really going for what is efficient here. And we'll notice as we look at our next try it out problem, this is going to come into play a little bit more because these are greater numbers, right? So we have 13 and 25 hundredths plus 12 and 2 tenths. So now we're in the teens. So some of these strategies are going to get a lot more difficult. So really, once again, thinking reasonableness, what would be a reasonable answer here? How do we know? And then we have those same strategies. We've moved from the math app for place value blocks to Didax because the Didax app has this big cube. Once again, we're going to see this is not going to be an efficient strategy for students. That's okay. We want them to see that. We want them to think, what else could I do? How is that similar? Maybe we're just moving them to place value discs. Maybe we're moving them into grid shading, whether it's from the slide or the grid from their packet. So here we are, same strategies. We're going to once again make that connection at the end, whether students chose to use this or not. We're making that connection to the standard algorithm. If the standard algorithm is really inappropriate for a class at this time, not a big deal, just delete it and insert images that work and make sense. But here you'll see kind of that completion of some of those strategies. We have practice here. If you did not use that video from the previous essential task, please use that for this. You'll also see that it says here to add your own strategies. So the blank strategy slides have all of these strategies in them. Add your own strategies, have students, based on what your students are meeting with the most success. So that is addition in a nutshell. We are going to now kind of switch our thinking over to subtraction. Our next two essential tasks are for subtraction. You're going to notice it's the same structure as addition. We're going to have these place value discs. There is a little X here so you can cross out discs as you go. And you'll notice that for the place value blocks as well. So you can cross out ones that you are subtracting away. Notice and look for students who build both numbers. So if I have 5/10 of an inch and 1 6/10 of an inch, if I'm subtracting, I don't need to build both of those, right? So kind of pay attention to that. And also think about, once again, reasonableness. What would be a reasonable answer here? What would make sense? And does our answer make sense? We have grids. Once again, we can show them here. We could show them here, whatever works. And we have those X's that you can cross out those grids. The standard algorithm is here. Feel free to delete this or not use this or share this with students if it's not appropriate for students at this time, especially since we want to make sure that they understand the process of subtraction with decimals. And really think we're making that connection here between how is this similar to subtracting with whole numbers. So there's another try it out that you can utilize and solve. really just practicing. Here is kind of all of those strategies put together. There's a sample anchor chart here using these strategies. Once again, this is only a sample. Anchor charts are made with our students and using student work. There is a Ready Common Core interactive video here once again. If it's not appropriate for your students, don't use it. It definitely does go into the standard algorithm. It builds up to that. If they need practice with whole numbers before they do this with decimals, please do that. Looking at our last essential task 55, same thing, we're going to have greater numbers, more place values. However, we're still going to see the same exact strategies. So disks, place value blocks, grids, standard algorithm. Once again, thinking what is reasonable, what makes sense, and we're really thinking about those questions as we go. There's two different try it outs here. And we'll notice some of these strategies are a lot of work, right? We're going back into some of these just really aren't as efficient as others. Regrouping, doing all these disks, doing all these place value blocks, it takes a lot of time and it's a lot of work. So is that considered moving forward? Are we going to still see that as an efficient and as an effective strategy? There are some Ready Common Core pages here that you can assign to your students. If you haven't done that video, that interactive video, definitely have them do that. And then you'll notice it says Ready Common Core 56 through 59. Pick appropriate problems for your students to solve. Kind of a mixture of addition and subtraction. So if you want them to have a combination of both, have at it. If you just want them to do certain subtraction problems or certain addition problems, you might want to select it that way. Thank you for listening. I'm sorry if this got a little lengthy, but please let us know if you have any questions or if we can help you in any way. Thanks.